Okay, so to go ahead and start with, let's talk about what the antiderivative is. So our antiderivative is capital F of x. And we're going to go ahead and make this definition, and this is the same definition in our textbook, as long as capital F prime of x is equal to small f of x. Now, what I'm talking about here is we are going to write this as the integral, and this S is my integral statement, of f of x dx is equal to capital F of x plus c. So what does all of this mean? So remember what we just said, that this inside the integral is our first derivative. So when we go ahead and have the integral symbol, which is this s here, of the first derivative, we come back with the original function, capital F of x. Now, a couple of rules that we need with this. If you have some constant times f of x dx, that's the same thing as pulling that constant outside that integral dx. And then the other piece of information that we have with this is if it is integral of f of x plus g of x, and that's both integrated about over the variable dx, and these variables have to match. That's the same thing as the integral of f of x dx plus the integral of gx dx. So now we're going to go ahead and do some examples. All right, so if we go ahead and start with 1 over 4x squared dx, remember I'm treating this as 1/4 times x to the negative 2 dx, and that's that rule where I said I go ahead and pull that constant out. So that will be 1/4 the integral of x to the negative 2 dx. So what I'm really asking myself is what would be my original function, f of x? What is it? Knowing that that derivative of that is equal to x to the negative 2. So in essence, we're doing this backwards. So when I go through and do that, we're doing the reverse of the power rule. So anytime I have the integral of x to the n, that's going to be x to the n plus 1 over n plus 1. This n plus 1 up here is the exponent, the n plus 1 down there is a number in the denominator plus my constant. So what I get there, if I go through and do this, the 1/4 stays outside, x to the negative 2 dx is just equal to 1/4 times x to the negative 2 plus 1 all over negative 2 plus 1, which becomes negative 1/4 x to the negative 1 power plus my constant. So we don't have anything that we can use for this. There is not a product rule or a quotient rule for integration. It doesn't exist. The only way we know how to do this right now is to go ahead and break that up and make that the integral of x squared over x to the 4th plus 2x over x to the fourth minus 3 over x to the fourth. And that is all about dx. We're going to bring those exponents up and make that the integral and reduce all of them. So that's going to be x to the negative 2 plus 2x to the negative 3 minus 3x to the negative 4. All of that is around dx. I now want to go ahead and integrate that, which means I'm going to add 1 to the exponent and divide by the new exponent. So that becomes x, that's going to be negative 2 plus 1 all over negative 1 plus 2 times x negative 3 plus 1 all over negative 2 minus x negative 4 plus 1 all over negative 3. And when I go ahead and do that and simplify it, I get minus 1 x to the negative 1 minus x to the negative 2. Those 2's just cancel out and give me that negative. Plus, and again, the negatives cancel out. And that's going to give me x to the negative 3. Make sure when you're doing all of this to keep that constant of integration there. So all of this now becomes negative 1 over x minus 1 over x squared plus 1 over x to the third plus my constant. To turn that all in the common denominator, that will give me negative x squared minus x plus 1 all over x to the third power. And again, don't forget that constant of integration. For the next example, I want to make sure I talk about what happens and what this dt in this case here means. Remember, this t is the variable that you're using, so that 14 comes outside and then it's just dt. So that would be a 1 there, correct? So if we think about it, what function would you have when you take the derivative of it would equal 1? And that would be whatever that original variable is. So this is just 14t plus my constant. So that piece that we're looking at for the variable is always indicated by that dt. And this is really important if we're talking about when we change our variables around. So when I have theta squared plus secant squared d theta, we're integrating again over theta. So when I integrate that, this becomes theta to the third power over 3 plus, now we always, let's talk about the derivatives of the tangent trig functions for a second. So dt of the tangent is equal to the secant squared. So that process now reverses. Now that means that the integral of the, put my theta back inside there, of my secant squared of theta is equal to the tangent of theta plus my constant. We'll do one more trig function. So if I have the integral of the secant of y times the tangent of y minus the secant of y dy. Well, let's go back to what I said before, is there's no product rule that we can use, so you can't use it this way. We have to multiply this out. I multiply that out and I get the secant of y times the tangent of y minus the secant squared of y dy. Now, we already went up before and we had and talked about what the derivative of the tangent was. The derivative of the tangent is the secant squared. Therefore, the integral of the secant squared is the tangent squared. So we have to go back with what we know. What is d? In this case, we'll use dy of what is equal to my secant of y tangent of y? Well, that is the derivative of the secant of y. So, once we recall that, we can go ahead and finish this out and say all of this is equal to the secant of y minus the tangent of y, and again, please remember to put that constant there.